Okay, so if we start over here, we're on 8.4, Proportionality Theorems, and it's on page 445. That's where it starts if you'd like to follow along. There's actually 3 theorems, 1 theorem and its converse, plus 2 other ones. And again, like I said, they're going to look very familiar to what we did the last couple of weeks. They're slightly different, so you may have a hard time, differentiating, keeping them straight from the other ones. I will try to help you with that. So the objective for our lesson is very straightforward. I want students to be able to use these theorems, proportionality, with parallel lines, and angle bisectors in triangles. So it's nothing tricky. I'm going to show you these. Oh, by the way, if you have colors, I'm going to color code, see if I can make this easier for you. Okay, and we're going to start right off the bat with the first one, triangle proportionality. If a line parallel to one side of a triangle intersects the other 2 sides. So TU is intersecting the other 2 sides, and those triangles tell us it's parallel. Then it divides the 2 sides proportionally. So it's the if we have parallel, then we can write this ratio. RT over RQ is equal to RU over RS. And that's a proportion. Remember, a proportion is 2 ratios equal to each other. So here's RT, that's the small triangle, and you're going to compare it to RQ, because that's the bigger triangle. And that proportion should equal, that ratio should equal RU divided by RS. So the small side over the large side equals the small side over the large side. And that's called a proportion when you have 2 ratios equal to each other. So if you have parallel, then you get this. We also have the converse. If you have lines dividing 2 sides of a triangle proportionally, then it's parallel. So if you have this relationship where RT is compared to RQ, and that's equal to RU compared to RS, if that is equal also, in other words, if that's what you start with, then you get parallel. So I tend to think of this as one theorem that's bidirectional or bijectional. That gives you the parallel lines. So if this is true, if this proportion is equal, then you get the parallel lines. So I know these pictures look the same, but they are different. One, you start with parallel and you get the proportions. This one, you start with the proportions and you get the parallel. And so we're going to use that theorem to solve this problem here. In this diagram, it's telling us that QS, I always like to mark it, is parallel to UT. It's telling us that RS is 4, ST is 6, not QT, QT is 9. That is a typo. QU is 9. QU is 9. And we want to find RQ. So we're going to call RQ X. Okay? So again, this same ratio holds. The small side to the long side is equal to the small side to the long side. So what you have to do is add these together. So RT is going to be 10. And RU is going to actually be 9 plus x. Okay, hopefully you can see how we added those together. Let me zoom in just a touch. But what this ratio is saying is RQ over RU equals RS over RT. So now I can just plug those numbers in. Okay, I get x over 9 plus x, and that equals 4 over 10. There's a number of ways to solve this. The easiest, of course, is just do your cross products. You could reduce that first if you want to. But I get 10x this way, and that's equal to 4 times 9 is 36, plus 4 times x. If I take away 4x from both sides, I get 6x equals 36, which gives me x equals 6. And since I was looking for RQ, and that's x, then this is RQ. 6. Any questions? Okay, just moving over a little bit here. So we're going to review just quick when we did logic tables. 2 of our logic statements are equivalent. So we're just going to review which ones the original conditional statement is equal to and which ones the converse is. So our conditional is our first one. That's the very first triangle proportional theorem. The way you state it is if P then Q. Okay? The other one that is equivalent to it is called the contrapositive. And that's if it's not Q, then it's not P. So we can use either the contrapositive or the conditional to prove something. Then the other one, the converse, is the second part, which means if Q then P. And the opposite of that is what we remember call the inverse, and that's not P then not Q. So those two are equivalent logically, and the first two are equivalent logically. And you'll see why we're doing this, because the theorems up here, you can say what the contrapositive and the inverse is as well. You just have to write it a little differently. So the triangle proportionality theorem says if you have parallel lines, then you get the proportion. So what the contrapositive says is if you don't have this proportion, okay, if you don't have the proportion, then you don't have parallel. The inverse is the negation of the conditional. So this one says if you don't have parallel, then this ratio is not equal either. Okay, so it's like 4 different ways, sort of, to use this, because when you get something like this, where it says, tell me if this is parallel or not, what you're going to do is set up a proportion, right? You've got 18, 38, 36, and 80. If I set up this proportion and it's not equal, then it's not parallel. Okay? So in this case, the way it's going to be is, let me do this highlighting again just to make sure. PQ over PR is going to equal PT over PS. Okay, so PQ over PR, we're going to just see if it's equal to PT over PS. So now we plug in our numbers. Okay, this one's 18. PR is going to be 18 plus 38, so that's 56. PT is 36, and then PS is 116. So you could reduce these both to their smallest form, or you could just grab your calculator and see if the cross products are equal to each other. Okay, if these two numbers, when they're multiplied, are equal to each other, then yes, they will be parallel. That's the way we do that. So let's just see what these numbers are. 18 times 116 is 2088. And 56 times 36 is 2016. So clearly those numbers are not equal, and that means no, not parallel. That's all you have to do is determine if they are or not. Okay, so any questions so far? Okay, so you can prove it's parallel or not. You can prove it's proportional or not. Okay, it is 2 pages of notes, so we're going to turn over now and do our other 2 theorems. This one's very handy, for especially city planning, things like that. And it's called the 3 parallel lines theorem. So here, let's read it through. If 3 parallel lines intersect 2 transversals. So here's the parallel lines. Okay, and here's our transversals. This one is L, and this one is M. Okay, so these are parallel and they intersect L. And L and M don't have to be parallel in any sense of the word. They're all over the place. But what we know here is that they divide the transversals proportionally. Okay, so what that means is if you have 3 parallel lines, okay, then you can write UW over WY is equal to VX over XZ. Again, I'm going to try to do these with so this over this is equal to this over this. That's what I wrote. Hopefully you can see this, that it has to be somehow in proportion if they're parallel. So we have an example here in Main Street and South Main Street. And we have our 3 lines this way, Main Street, South Main Street, 2nd Street. And it says that angle 1 is congruent to angle 2 is congruent to angle 3. Now, we need to know that first. Can anybody think of why we need to have that fact before we can solve this? Okay. I'm not hearing any volunteers, so I'll go ahead and keep going on. We need parallel lines before we can use this theorem. These, if they're all 3 the same, mean that those are corresponding. I hope you remember that. Remember, if we have corresponding angles, then we get parallel lines. So in order to say that these are parallel, we have to have that. So now we know they're parallel. Now, GF right here is 120. DE is 150. CD is 300. And we want to know the distance HF between Main Street and South Main. So this is what we are looking for right here. I don't know GH, but I can figure it out. But first I'm just going to call it X. Okay? So, you know, in a perfect world, I can write this proportion right here. I can write 120 over x equals 150 over 300. So you've got these proportions. The transversals are here and here. So it's 120 over x equals 150 over 300. And then I can solve it. I actually notice here that if I reduce this, this turns into a half. So 120 over x equals 1 over 2. This gives me x equal to 240. Now, I don't think I answered the question yet because it says find the distance HF. So HF is from here to here. What I found was x. So HF is equal to 240 plus 120. So that would be 360 yards. And that's the answer that we put in. Remember, always answer the question being asked. Any questions about this parallel line theorem? It's really handy. These are kind of fun to solve, actually. You'll get better pictures in your BIM assignment. Last, I have one very similar to the beginning, only now it's in a triangle. Instead of parallel lines, the same kind of thing happens in a triangle. First of all, you have to have a ray bisecting an angle, so you need those two to be the same. But if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So if you have an angle bisector, here's what you can write. You can write that AD over DB is equal to AC over CB. So let's trace that again. So if this bisects it, which I know because of that, then I can write AD over DB equals AC over CB. Maybe I should have done it the other way with the colors here, but here's how I think of it. The small bottom over the long side is equal to the small bottom over the long side. Or you could do the bottom of the first triangle over the bottom of the second triangle equals the side of the first triangle over the side of the second triangle. So really I should have colored those a little differently. Sorry. Okay, so this is the AD to DB. So this is like the bottom, and these are the sides. But you can change it up. You'll still get the same answer, of course. So we'll go on and I'll show you some examples here. So if I have a triangle like this, I'm looking for x. Here's x. I see that it's been bisected. So that means I can write, just go straight to right here, 14 over x equals, if you did 14, then 24 has to go on top. 24 over 48. You could just go straight there. And I notice that this is equivalent to 1/2 when I reduce it, and so x is 28. So it's very straightforward. It's another theorem in your bag of tools there. Number 5 is slightly different. Same theorem, slightly different, because now instead of having both parts, I have all of this here. And this example also is in the other video that I made, but if you look, use the given side to find RS. So RS is x, that's what we're looking for. But this is not marked, okay? We have to have that marked. So if from here to here is 15, and this is x, then what's left over is 15 minus x. if you didn't learn that trick in algebra, learn it now. It's very handy. Okay, so what you can do is write this proportion. 15 minus x over x, so small bottom over the longer part of the bottom, equals the side over the longer side. Easy peasy. We are going to cross product this out. Let me go here. This one gives me 7x, right? And I don't know what 13 times 15 is, so I'm just going to grab this. 13 times 15 is 195. And then don't forget to multiply the x by your 13 too. Okay. So then if I add 13x to both sides, I get 20x equals 195. I'm going to come up here so I don't mix up any numbers here. Okay, so 195 divided by 20 gives me 9.75. And since it said find RS, and RS is x, then we're good. Okay. Again, any questions yet? There. So using the angle bisector theorem, I have a third one. This one is very straightforward. Just bam, solve it. This one, you took an extra step to do that, and this one takes 2 extra steps. So they're in varying degrees here. And I want to find FG. So here's FG. I know that from here to here is 14. I already told you how to do that little tricky thing there. That's going to be 14 minus x. So this is going to be slightly different, but very close, because you'll see. Okay, so I'm going to write x over 14 minus x. I know that because these are bisected. So x over 14 minus x goes here. X over 14 minus x equals 8 over 12. There's a couple different ways to do this. Again, you can just go straight to the cross product, or you can reduce this first. I see that 4 goes in there twice and 3 goes in there. I will eventually, of course, have to cross multiply to get that product. But it's always easier when you make the numbers smaller. So this gives me 3x, and this gives me 28 minus 2x. I'm going to add 2x to both sides. And then when I divide 28 by 5, again, I'm going to grab this. Whoop. 28 divided by 5 is 5.6. And I wanted to find FG. Now, here's the thing. I found x. X is here. FG is 14 minus x. So, to find FG, I have to subtract this. Okay. Let me go ahead and subtract 14 minus 5.6, and I get 8.4. So the process was the same, but you had an extra step because you had to answer something differently. So this is all the notes we're going to do for today.